Hey everybody. Today we're going to look at equations that are a little different than what you're used to. You guys are used to probably solving for a variable, and it's the only one in an equation. But as you can see down below for this formula, which I hope is very familiar to you, this is the perimeter of a rectangle is equal to 2 widths plus 2 lengths. If you add up all the sides of a rectangle, you get the perimeter. There are times when you want to solve for the width or for the length within a formula and leave the variables as variables. And there's lots of reasons for doing that. I'm going to show you a very specific example of where it comes in handy. But let's get started and actually do one. Now, in general, when I've seen the problems presented in books and sometimes on exams, they'll underline the variable that you're supposed to solve for. So I will keep that I'll do it that way myself. And let's get started. So what I've done here is I've set up a side-by-side example. I like to do this a lot because most of us are familiar with this one where we're supposed to get the x by itself. And so I'm going to do these problems side by side so that you can see it's very similar operations that we follow. Most people are aware that if you wanted to solve this equation on the right for x, we would do the opposite in reverse order to both sides. The last thing we did on this right side over here is add 4. So in order to solve this equation over here, we're going to subtract 4 from both sides. And just like that, when I want to solve for w here on the left, I want to subtract the 2l so that I can get w by itself. So hopefully this will make sense to you and you'll be able to see that there's nothing really new here. It's just we have to leave the variables as variables. We can't really do the operations on them. For example, 18 minus 4 is of course 14. And that's fine. You can do this subtraction and I'm left with 2x on this side. Now over here on the left, and of course the 4 minus 4 is 0. 2l minus 2l is 0. But p minus 2l, I can't subtract those. So I have to leave them as a subtraction, like this. Now I still want to get w by itself, just like I wanted to get x by itself over here. I've noticed a few people writing the division sign like this. In algebra, that's really a bad idea. It tends to get really confusing and kind of clunky. So I prefer to use the division line like this. I'm going to divide both sides by 2. Some people are a little confused about what happens here. Well, 2 divided by 2 is really 1. They don't just disappear. They're really 1, and 1 times x is x. And divided by 1 is still x. So I have x all alone over here, and it's equal to 7. Again, I could do this division. 2 goes into 14 7 times. Now on the other side, I'm going to divide by 2. Now it's important that you remember a couple of things. If you divide this side by 2, you have to divide the entire expression by 2, or the entire side by 2. And you're going to simplify the 2 with the 2. And you are going to be very tempted to make a huge mistake at this point. A lot of students are going to be tempted to cancel this 2 in the denominator with this 2 in the numerator. Here's the 2 in the numerator. You're going to be tempted to cancel those 2. You cannot do that because this 2 in the denominator is literally a common denominator. Now we could just leave it the way it is. It's correct the way it's written. In other words, w is equal to p minus 2l all over 2. This is a perfectly acceptable way to solve this. If you did, however, want to cancel that 2, you would have to divide it into a common denominator. So you would have to separate these fractions out. P over 2 minus 2l over 2. Notice that I separated out the fractions with a common denominator, and it's equal to w. And now the 2 can be canceled with the 2. So I end up with p over 2 minus l, or p minus 2l over 2. Both are correct, This is probably the most common answer that you're going to run across. But occasionally, they're going to simplify the expression and they're going to write it in this way. And I'm going to rewrite it so it looks a little bit nicer. It would be P over 2 minus L is equal to W. These two expressions are exactly equivalent. There's no difference between this expression over here and this expression over here. They're the same thing. And both are the same, two ways to write the same thing. So we've solved for W within the formula, the perimeter equals 2W plus L. Now I'm going to do another one where we have an area. Area equals length times width. And again, I'm going to do a side-by-side comparison. If I want to solve for the length this time, let me underline the length real quick. Oh, darn it. I'm going to have to get rid of that. Just a second. Sorry about that. There we go. If I want to underline, there we go, the length, I'm going to solve for the length. If I underline the width, then I would solve for the width. In this particular case, since I solved for the length last time, I'm going to go ahead, I solved for the width last time, I'm going to solve for the length. So in this case, I'm going to divide by 2 on both sides. Keep messing up. Simplify the 2's and I get x is equal to 8. This time I want to solve for L. So hopefully you can see that I'm going to have to divide by W on both sides, and then I'm done. That's it. A over W is equal to L. I got the L all alone. Very simple, one-step equation. You will almost certainly see a problem like this one or like the previous example on your exams and on your practice tests. This one is probably a little less common. This is the area formula for a triangle. And I'm going to show you a trick that we use very often in algebra. A lot of students don't like fractions. They want to change them to decimals, or they would really like if there were no fractions. And keep in mind that in algebra, you can do anything you want to both sides of the equation. So what I'm going to do is I'm going to eliminate that 1/2 by multiplying both sides of this equation by 2. I'm going to multiply this side by 2, and I'm going to multiply this side by 2. That's going to give me 140 is equal to, now look at this, the 2 simplifies with the 2 to just give me x times 5, or 5x. And now I can solve it very simply without a fraction. I'm going to divide by 5 on both sides. Now watch what I'm going to do on the other side. Here on the left side, I don't like this fraction, so I'm going to multiply this side by 2, and I'm going to multiply this side by 2. And that is going to eliminate my fraction. Now some people are going to say, well, don't I have to distribute the 2? This is one term. If there were things being added together within those parentheses, then I would have to multiply both terms by the 2, or all 3 terms if it was a half plus b plus h. In this particular case, this 1/2 bh is one term, and when I multiply by 2, I'm just multiplying the 2 times the entire expression, or times the entire term. The 2 simplifies with the 2, and I have BH is equal to 2A. Just like over here, 2 times 70 is equal to 5x. Now I wanted to solve for x, so I'm going to divide by 5. And some people are going to grab their calculator. Not a good plan. That happens to be 28. I used a trick called the double and half method, which I'll teach sometime in class. Hopefully you'll like that one. I'm actually using the reverse of the double and half method. Now on this side, I want to solve, and I forgot to tell you, I was going to solve for the base. So we're going to solve for the b. And in that case, I'm going to have to divide by the h in both sides. The h's simplify out. And of course, the base is equal to 2a over h. If I had wanted to solve for the h, then I would have divided by b on both sides, of course. So the base of a triangle is equal to 2 times the area divided by the height. And it's very useful to be able to manipulate formulas and solve for a variable. And I'm going to show you why. I'm going to give you one last example. And this is a common formula. Hopefully you recognize it. This says that Fahrenheit temperature is equal to 9/5 times C, the centigrade or Celsius temperature, plus 32. Now I'm going to solve this for C, but here's why I might want to do that. What if I know the temperature in Fahrenheit? Most people are pretty clear on Fahrenheit temperatures in the United States. But if they want to know what the Celsius temperature would be, they would have, and they only knew this formula, they would have to substitute the Fahrenheit in and then solve for the Celsius. And in this case, I'm going to go ahead and solve it. Some people would like to multiply everything by 5, which would work. I could multiply both sides by 5, and I wouldn't have to deal with the fraction. But I want to show you what to do with a fraction on occasion when you do have a fraction as a coefficient. So we're going to subtract the 32 from both sides. And I get 9/5 C all alone. And over here, we've got 45. Now, I want you to think about the fact that I could do the opposite to both sides, divide by 9/5. But when we divide by fractions, we always end up multiplying by the reciprocal anyway. But think about it another way. What if I wanted to get rid of this fraction by simplifying? Wouldn't it be nice to have a 5 to cancel with this 5? And wouldn't it be nice to have a 9 to cancel with this 9 so that C is by itself? Well, that is exactly what I'm going to do. I am going to make it so. If that's what I want, that's what I can do. Remember, you can do anything you want to both sides of an equal sign, so long as you do it to both sides. Now watch this. 9 divided by 9 is 1. 5 divided by 5 is 1. And you now have a method for eliminating fractions if they're in the coefficient. You multiply both sides by the reciprocal. Now, when I multiply fractions, a lot of people are confused. What do you do with this 45? Well, this is really over 1. And the 9 divides easily into the 45 to give you 5. And 5 times 5 is 25. Now, what that tells us is that if you have a temperature in Fahrenheit of 77 degrees, it represents a temperature of 25 degrees Celsius. Now, why would I want to go through all that trouble for solving for C in this one? And I'm going to show you. The first step is just like over here. I'm going to subtract 32. And I end up with F minus 32 is equal to 9/5 times C. Again, I have a fraction in front of, in the coefficient of this variable. So I'm going to multiply by the reciprocal to eliminate it. I'm going to multiply by 5/9. Very common mistake is to forget that I'm going to multiply the entire side by 5/9. And the 5 simplifies with the 5, and the 9 simplifies with the 9, and I have C all alone. And I have C is equal to 5/9 times F minus 32. This side is the same as I just switched sides for this. Now, why would I want to do this? Here's why. If I have a bunch of temperatures in Fahrenheit that I want to convert to Celsius, I could go through all this trouble every single time and solve my formula for the C in each case. Or I could solve the formula once for Celsius, and now I can just substitute in my Fahrenheit. In this case over here, we can put this 77 degrees Fahrenheit into our new formula, which is 5/9. The Fahrenheit temperature was 77 minus 32. So the Celsius is equal to 5/9 times the 45, 1, and we get 25 degrees. Without doing any solving at all, we have a entirely new formula that gives us a Celsius if we're given the Fahrenheit. That's why you want to be able to manipulate and solve literal equations. So I hope that is clear, and you should practice yourself a little bit. So make sure you do at least this one practice problem. I even included the side-by-side problem to go with it. So make sure that you can solve this for L. Obviously, that's going to be one of the questions that's going to be on your do now. So learn how to do it, practice it, and try it. And I will see you back again.